Take 3. Let me see if I can get my words out properly this time. I'm gonna go straight to the point. What we got here is something to help you assist in recording desktop videos. It's just a phone holder, a phone cradle. I haven't really got a name for it as such, but we all know what we're looking at. And this is an exercise in friction and an exercise in seeing just how far we could take a 3D printed product to the point where you could almost sell it. And I feel like I could almost sell this and be happy with somebody receiving this. But in my opinion, 3D printed stuff is just cheap, tacky, nasty stuff if it's not done right. Without much further ado, let's go into the design philosophy and some of the elements of producing this that I've overcome, and you'll be able to see the final product and see the final results. I'll speak through what the intention was, some of the challenges that I've gone through, and kind of like how I approach 3D printing. I approach this not as a printer. I don't like the printing game. That whole you make a bunch of rubbish on plastic rubbish and you just put it out there on the internet and the next person scroll to the next video. I like making useful stuff. I like making stuff. I like making useful things, and I like making innovative things. But I think this is going to be pretty cool. And you know what? I've got it right next to me, and I think it works pretty reasonably. So let's work through our way through the design. We've got a little bit of a clamp here. Same sort of a philosophy as a vice, and your table would be in between here, and this rotates within the thread of that tapped plastic. If you've never 3D printed a thread, there's a little bit of a design guide that you got to follow with this. Obviously, with the modeling software, you can model the thread and you can model the tap and everything, and you just got to offset these surfaces a little bit. I think it's about 1.115 I've gone with. That seems to work very well. Offset surface away from this, and it threads through pretty nicely. You can see where I've put the connection points inside of this model here. Wherever you see a hole like this, I've put a screw in there somewhere. I'm not a big fan of infill, and you're printing something that's like this, and it don't really come out nice sometimes. You got to scrape off all that infill. I will add a connection point where I got to put a mechanical fixing, and that's really what I'm into. I'm a mechanical design engineer, and you can see some of the principles I like to put into these hobby stuff, right? So we got a connection point over here. Countersink screw goes all the way through here. That's a nice fixing that goes through there. We can see this base plate sits inside of this cradle, for one of a better way of phrasing it. I'm gonna put a section through view here, and you'll see what's going on behind there. You can see that, and that rotates inside of that assembly. So this is free rotating. You'll see in the finished product. The same principle with the bolt and nut here we've taken from here. 2 arms. That's the same, and the third arm, it's a little bit different. And you can see again, I've used a mechanical fix into this. This is a separate print. This prints nicely on its own. This piece here, and this prints nicely on its own as well there. And we just got a bolt that goes through there, and this is sort of hanging down via gravity, and you can adjust the width or the gap in between here for a different size foam, whatever. And again, we've just gone with a nut and bolt configuration over there. So it's pretty simple design. It works pretty well. And we see it a little bit later on. And I like it. But yeah, let's move on to the real video. Ooh la la! Now we're in the real world. Let's take a look at this in the real. This is the printout. This is the final thing as it's been manufactured. It's pretty okay, pretty stable. I can adjust this to a certain point without having to retighten those nuts and bolts. I think the most expensive thing about this, funnily enough, is 2 things really. 2 things are really expensive about this product, which expense is relative. This is mostly filament, which is pence per pound. Okay, it's cheap. But the most expensive thing is these shake-proof washers that I've got over there. That's the most expensive thing about this product, and I think I bought about 6 of them, and it came up to about £10 for not 6 of them, 10 of them, about £1 a shake-proof washer. But that's what's keeping. Although the plastic bolts is pretty good to to keep everything in alignment where you want it to be. It's really those shake-proof washers that are doing the heavy lifting when it comes to keeping everything together. And again, like I showed you, I can still adjust a little bit before I reach the limits of the friction within the system. That's starting to get loose, but I can adjust it a little bit, and it works pretty well for what it is. So that's the final product. Let's go for another spin. Up and down, and then underneath, that's what's keeping it planted to the table. There you go.